Deep learning is a new field in AI that promises to revolutionize the world as we know it. Deep learning strives to solve an optimization problem. It relies on the principle that almost everything can be described as a complicated mathematical function. Deep learning uses neural networks. It starts by taking inputs, multiplying by some constant called a weight, and adding another constant called a bias, and applying a nonlinear function. It does this over and over for each layer. The most challenging part, however, is determining what these constants should be. This requires a bit of calculus. First, we need a function called a loss function. The loss function is the measure of error in the performance. The higher the value, the worse the performance. One common loss function is called mean squared error. First, the neural network makes a prediction y hat based on its weights and biases. It then subtracts the actual value of y and squares it, so it is never negative. After that, we can use calculus to calculate the gradient, aka the derivative or the slope of the loss function with respect to each of the weights and biases, and use this to descend the function until it is minimized in a process called gradient descent. Of course, this loss function usually won't be two-dimensional or even three-dimensional. The loss function can have hundreds, thousands, or even millions of dimensions, and we will need to do gradient descent for all of them. Let's go through an example. This model will take an input image and predict whether it is a cat. It will output 1 if it is a cat and 0 if it's not. Let's take this image for example. We can flatten the pixels and represent each pixel as a number representing its intensity between 0 and 1. We can feed this into our model and predict whether it is a cat or not. In this case, it outputs 0.3, meaning it thinks there's a 30% chance it is a cat. This is not very good, but now we calculate the derivative of the loss function and update our weights and biases. If we do this for hundreds of images, our model does much better. If we plug in our image again, it predicts a 93% chance it's a cat. This is much better. Finally, we will go over how the algorithm is actually implemented. Each layer has a matrix, which is like a 2D list of numbers to store the weights. It stores the biases in a similar way. Then the input is multiplied by the weights in a clever way and added. After, the bias is added and the output is fed to the next layer to repeat the process. Neural networks have thousands of applications, from image classification for self-driving cars, to face generation technology for more realistic game avatars, to making fully functional talking chatbots. If nothing else, one thing you should take away from this video is that a little bit of mathematics can change the world.